Welcome to the lecture Matrix CAD Prosthetic Design. In the Matrix workflow, we already placed the Matrix implant and also did the impression, and right now we are able to CAD design Matrix Prosthetic. Before we can start using the Matrix Prosthetic library, we have to make sure that we download the library either for ExoCAD or 3Shape, and also in the download you can download the manuals and also the quick guides which help you to always design Matrix Prosthetic in the perfect and correct way. In your responsibility, it is that you have to make sure that you always use the newest version of the libraries. So if there is an update, the TRI Academy will send you an email with the software updates, and you have to make sure to immediately install these updates and use only the newest version of the CAD libraries. Let us start with the CAD, the data capturing analog or digital. So on this slide you can see that our 3D touch is not only a scan body, it's also an open tray impression pose. So if you use it in the intraoral scanner as a scan body, you have the data digitalized immediately. If you use the analog way, you use the open tray impression pose, the 3D touch, and do a silicon impression and go further with a digitalization with the model scanner. And then when everything is digitalized, you can import the data either in ExoCAD or 3Shape CAD software. Detecting the scan body is important to understand which differences of scan bodies the Matrix systems offers. So here we start with the platform 3.7 and platform 4.5. The Matrix implant has a platform 3.7 and a platform 4.5. Therefore, we have first of all a color coding. 3.7 is gold anodized and platform 4.5 is silver anodized. Also, to recognize this difference between the platforms is on the side of the scan body. You can see for platform 3.7 a flat surface. For platform 4.5 there is a groove on the right side, and on the left side is a groove going down. So this is how you can detect the difference between platform 3.7 and implant platform 4.5. Second difference between the different scan bodies is the height. There is for platform 4.5 and platform 3.7 always a short and a long scan body. And so it's important that you see this difference. And for the short scan bodies, we have always one inclined edge on the right side here. You can see that it's a cutting edge. And for the long scan bodies, we have always two cutting edges. So this is how you can differentiate the length and a short and a long scan body. Okay, after detecting, it's necessary that you align after a standard procedure, as you know it from any other implant scan body in your 3Shape software on the left side, or also in your ExoCAD software. By this example, I will explain that. You have the red dot on your virtual scan body, and you have to align this with your digital model in the software to be able to define the position of the implant. The same thing you would do with ExoCAD. You have here this red dot alignment, and then you have to give the software the position of the scan body on your digital model. Okay, after scan body alignment, we have basically 3 steps to follow to CAD design Matrix Prosthetic. First step is the platform which you have to choose. You know already it's platform 3.7 and platform 4.5. The second step is interface choosing. So if it depends on if you design a bridge work or a single crown. And the third step is to choose the right screw for the chosen material in what you want to produce the prosthetic later on. So going a little bit more into details of these steps. First, select the right platform. Platform 3.7 is golden anodized. Platform 4.5 is silver anodized. Make sure that in the software, when you choose in ExoCAD or 3Shape, when you start designing, make sure that you choose the right platform in combination with the right scan body. After the next step is select the right interface. So to mill and produce matrix prosthetic, we are able to produce single crowns or full arches or 3-unit bridges. These two, the rotational and the non-engaging designs, are the designs you have to choose or select for bridge works. And then there's the engaging version, which you choose for single crowns, for rotational fixed prosthetics like healing colors, individual healing colors, and so on. You would use the engaging version. Step 3, make sure to select the right prosthetic screw in combination with the chosen material. So the matrix offers you different screw designs. The first one is here the 2.25 screw, which you use for metal restorations. Metal restorations in chrome cobalt or even titanium are done always with the 2.25 screw. The next screw is the 2.6 millimeter screw. This screw is only used by when you do an angulated screw channel up to 30 degrees. This screw, and this is an important information, always includes an angulated dynamic screwdriver. This is a special screwdriver to be able to screw retain the angulated screw channel, and only use this screw for angulated screw channel. Your main screw in the system is the 2.8 millimeter L screw, which you use for zirconia, for PMMA restoration in any case. Only in very, very limited occlusal space, we have a second 2.8 screw, which you can see here the difference. It's a shorter screw, and comparing to the 2.8 L screw, but make sure that you have the 2.8 L screw as your standard screw by designing a matrix prosthetic. Important information is talking about designing. When you design the matrix prosthetic, it is in your responsibility that you never change the height of the screw seat. As you can see it here, the height of the screw seat is given 1.3 millimeter. Do not change in any case these parameters, as well as you never should go narrower as 0.9 millimeter in the horizontal, in the vertical way here. Don't limit this 0.9 millimeters. This is really in your responsibility. If you change that, you lose the lifetime warranty of TRI, what gives the TRI to you. Here is an example on the right side in Exocad or also in 3Shape. You can always see this minimum wall thickness shown here in red. And so when you design the matrix prosthetic, make sure you don't go below this red area, and always have enough thickness to have a secured prosthetic. Here's some design warnings. So make sure to keep platform clear. You can see here some bad examples where the platform is not, as you can see it here. Here you see the 20 degrees flat part of the platform, the connecting surface into the matrix implants have, like for example here, an over contouring. And when you have this over contouring, it's not sure that your prosthetic will fit perfectly on the matrix prosthetic. And just to show you a good example, you can see here on the left side a very clean surface. There's no over contouring of the design of the matrix prosthetic. Make sure that around the matrix prosthetic is always a clear free area for the connection of the matrix. Export CAD to CAM. So after designing, here in the example, a single crown, we have to export this data to our CAM system. Here is just to mention that you have always to include for 3Shape the PTS files, and for Exocad the construction files. Include them always and send it to the CAD to the CAM manufacturing. Here, another warning: it is absolutely necessary that you only use a CAM machine which is certified by TRI and have included all the milling strategy necessary to mill the perfect connection, the perfect matrix connection. If you mill on a not certified matrix, not matrix certified machine, you lose again all our lifetime warranty. Download and print out our manuals, tutorials, and the useful quick guides. So it is necessary that after this step you are able to download either for 3Shape or for Exocad all the libraries to install them on your software. Plus you can download useful tutorials how to design matrix prosthetic in details. And we have also included the so-called quick guide, and the quick guide is either for Exocad or for 3Shape available, and this is necessary, or better, you print them out and have them on the desk when you start designing matrix prosthetic, and all the steps which I just explained in this presentation are on there on a one-side page, and you can follow this very clearly, and it makes sure that you have always a perfect design matrix prosthetic. Last but not least, here's a checklist with all the points which are very important to guarantee a perfect CAD design. Please take a look at this checklist, and so you are sure to have a perfect CAD design on the matrix system. Thank you for listening. See you in the next part.